In this video, we continue with the slides we started in the previous video. In this slide, we were looking at the contents of the intermediate table. We observed that there are three columns. The first column is the primary key of this table. The second and third columns are foreign keys that link to the Pop-Tart flavor ID and Kroger store ID fields in those tables. So the intermediate table has no useful information for human beings, but it serves an important purpose of providing a way to create a many-to-many relationship between two tables in which human beings are interested. We can write a select statement to join all three tables and produce useful information. I suggest that you grab a copy of the sequel that I provided in the slide and that you jump back over to SSMS and execute that query. The results are a little bit jumbled, but we should study them closely. Notice that we did a select star just to get everything from every table, and then we can break it down a little bit. The first 1, 2, 3, 4, 5 columns are from the Kroger store table, and we know that because in our from clause, the first table we mention at the top of the screen is the Kroger store table. So that's all the columns from that table. The next three columns are from the intermediate table. There's the primary key from the intermediate table, and there are the foreign keys in that intermediate table. And we know that because the second table in our inner join is that intermediate table. The last two columns in the results set are the primary key of the Pop-Tart flavor table and the Pop-Tart flavor from that table. And we know that because our second inner join refers to the Pop-Tart flavor table. It joins that result set with the result set from the previous inner join. We're intersecting all three tables and asking for all the columns from those tables and all the rows that are part of that intersection. The natural language description of that would be what are all the stores that sell Pop-Tarts and what are the flavors being sold. And that is the intersection of Pop-Tart and Kroger store and the intermediate table, which is the foreign key relationship between those two entity tables. And to be correct, this should be dashes. Pretty obvious that it didn't turn green. We need to fix that. Now we can filter this down because we've provided a lot of information here that might not be useful in a result set. It might be, depending on the audience that was going to be using this result set. But we could certainly Kroger store and Pop-Tart flavor. Then when we run this query, get that T out of there, we'll only get two columns. And I probably need to provide a store name, and the name of the store field is store name, not Kroger store, my fault. Running that then is going to give me the store name and the Pop-Tart flavor. To be more precise, I could put PT in front of that. Run that query. We've reduced the result set dramatically. Now we have the store name and the flavor being sold at that store. This is a lot easier to deal with from a human being perspective. Notice that the Mount Orab store sells a whole bunch of Pop-Tart flavors. All the way from the third row in the results set down to the 23rd row, approximately 20 different flavors sold at that store. And if you scroll through this, you will see that some of the stores just sell one flavor. There's the Colorado Springs store that just sells pancake. I'm sorry, it actually sells two, pancake and arachnid, which is pretty gross. The Beachmont store only sells green onion. The Goshen store only sells pomegranate, and so on. What's missing from this table is also interesting. Since we're answering the question, what are all the stores that sell Pop-Tarts and what are the flavors being sold, we are excluding from this query stores that don't sell any Pop-Tarts and Pop-Tart flavors that are not sold at any stores. The reason we know that is because it's an inner join. We're intersecting the tables that have common values in those fields. If the tables do not have common values, those rows are excluded from this result set. To give you a little more detail on that, let's order by store name, just to give us a better handle on what we're looking at. Now the store names are in alphabetical order. There's Amelia, Annex, Anderson, Batavia. Remember, these are just silly store names. They're not meant to be real. But let's look at the store table. And let's look at all the rows in the store table. If I scroll down, the very last store is 1080 or Lebanon. And if I go back to the query that we are playing with and I search through to the L's, there is no Lebanon. There's Lima or Lima, there's Kroger, there's Loveland, but there is no Lebanon. That tells me that even though we have a store called Lebanon in the store table, it must not sell any Pop-Tarts because it did not show up in this query. What are all the stores that sell Pop-Tarts? In other words, only show me the stores that have corresponding records in the intermediate table. Don't show me any stores that do not have corresponding records in the inner table. Let's flip back to the slides. Move to the next slide, slide 14. Let's do some practice. What store sells flavors with chocolate in the name? Back to SSMS. Clear this comment. And I can quickly answer that question by adding a where clause. Since this query tells me all the stores that sell something and all the flavors that are being sold, I've already got more than I need, but the result set just needs to be filtered. I want to filter on Pop-Tart flavor. And I'm saying only show me the flavors, if I spell it correctly, that have chocolate in the word in their flavor name. And this looks really bad. It should not take this long to run. As you can see, I've got an error message. An error occurred while executing batch. Error message is execute reader requires an open and available connection. It looks like I've been logged off of the VPN or logged off of the SQL Server machine. So I'm going to pause for a moment and try to reconnect. After a brief bit of debugging, I learned that I was logged off of the VPN. For an unknown reason, I went ahead and reconnected the VPN, restarted SSMS, reestablished a connection to our SQL Server, and now I notice this query needs to be adjusted because instead of the equal sign, I need like there. Let's see what we get. There we go. That gives us the store names and the flavors sold at those stores that have the word chocolate in them. Remember that this syntax is not case sensitive, therefore it picks up a capital C in chocolate or a lowercase c. And there are two stores that sell a flavor with the word chocolate in it. The Mount Carmel store sells white chocolate, and the Mount Orab store sells 3 different flavors with the word chocolate in them. If we flip back to the slide, on the following slide, number 15, I have provided a solution which is almost identical to the one that we just wrote in SSMS, except I had included an order by clause because it was left over from something that we did earlier. But we are joining 3 tables together. Foreign keys are in the intermediate table. Primary keys are in the store table and the Pop-Tart flavor table. And we're setting a filter to exclude everything that does not have the word chocolate in it. And it is a case insensitive filter. It doesn't matter if chocolate is uppercase or lowercase. It will be included. Here's another practice query for us. What are all the stores, even the stores that don't sell Pop-Tarts, and the Pop-Tart flavors sold in those stores? We have a little different requirement here. We want to see all the stores, even if they don't sell anything. If I give you a query like this on an exam or a homework, I will try to be this specific. It is a requirement that you must bear, that you read these queries carefully and understand them before you begin to work, because there is a significant difference between asking for all the stores and asking for only the stores that actually sell Pop-Tarts. Remember, there could be some stores that don't sell any Pop-Tarts, but they are still in the store table. We saw the Lebanon store, for example. And there will be Pop-Tart flavors that are in the Pop-Tart flavor table that are not sold in any stores, which makes sense in the real world. There may be some Pop-Tart flavors that Kroger just does not stock, and there may be some Kroger stores that don't have a demand for Pop-Tarts. That's kind of hard to imagine because Pop-Tarts are wonderful and delicious, but it is possible. Thinking about this query, then, we're going to need to do some outer joins because we want all the stores, even if they don't have a corresponding row in the intermediate table. Think about Venn diagrams in the joins video that you have watched earlier in the semester, because the left outer join gets everything in the left-hand table of the join and only the records in the right-hand table that match. Here's a solution. I've already typed it in because it's easier than watching me type the whole thing in on a video. And when I run this, I get everything from all 3 tables, which we've seen before. The star says select everything from all the tables that are mentioned in all the joins. And it looks pretty good. There's the primary key in the store table. There's the natural key in the store table. You can see Mount Orb shows up a whole bunch of times. They sell a lot of flavors. Scroll all the way to the bottom. There's Lebanon. There's our friends in Lebanon who don't sell any Pop-Tarts. They still, however, show up in this result set, which is exactly what we want. It says all the stores, even the stores that don't sell Pop-Tarts. That's why the left outer join between the store table and the intermediate table is so important. We get everything on the left side of the join and only the things on the right side of the join that match. That gives us all the stores. Again, look at the last row in the result set. There is no Pop-Tart flavor. It's simply null because there are no corresponding records in the intermediate table that match Kroger store ID 1080. And this is perfectly fine. Whoever is using this results set will have to be aware of that situation. They asked for all the stores, and they have to understand that some stores may show up in the results set and have a null value in the Pop-Tart flavor. That's perfectly fine. You wouldn't want to print that on a report. You wouldn't want to put that on a web page. But as long as you know how to deal with it in some other way, like writing another query that filters it out, or writing some code, some programming that eliminates that null value in there, or explains to the user what's going on, this is a perfectly valid result set that has a lot of useful applications. Back to the slides. On the next slide, there is the solution that I just provided. The screen snip is a little bit out of date, but that's okay. I gave you the text there towards the bottom of the slide. You can copy that text, you can paste it in to SSMS if you haven't already typed it in on your own, and you can see the results that we get. We've already done this slide. Let's ignore that. Actually, that slide will be removed when you get the slide set on Blackboard. And to sum up the presentation, here are 3 rules you can memorize. If you have a foreign key and you have defined a relationship between 2 entities, between 2 tables, this set of rules will tell you what to do when you're creating those tables. If it's a one-to-one relationship, you can put the foreign key in either table. There are some rules about that, but at this point we don't have to worry about those rules. If you see a one-to-one relationship between entities, between tables, put the foreign key in either place. One-to-many, the foreign key goes in the table that is on the one side of the relationship, not the many side. Many-to-many, as we've just seen in the previous slides, you need an intermediate table. In that intermediate table is a foreign key from each of the 2 entity tables that are being connected through that intermediate table.